So it was, it's created by University of California, Davis.
Yeah.
And they developed it to, like I said, to teach children watershed and kind of atmospheric sciences and kind of teach them about how water flows. It's programmed to kind of like evaporate slowly over time. And the idea was that it could go into museums, and it's something interactive that kids could play with very little supervision. But it's still super interesting and entertaining.
So they can walk up to a box of sand and
Yeah.
start playing with it. They don't have to have any adult supervision around them while they do this.
Yeah, and you can show them the basics and then just kind of let them play and explore. And it's the basic concept of it, technology-wise, is actually kind of simple. It's just we have a 3D camera up here that takes an image of our sandbox, but instead of like capturing colors of each point, it captures the depth of each point. And then we use point processing to just kind of pseudo-color it based on how deep or how far away from the camera everything is. So since these red spots are closer to the camera, we're going to we decided just kind of arbitrarily to color them red, or the lower portions we color them blue because that's what you have on topographical maps.
So the red are the mountains and the blue are the water.
Just high points. And then it uses, I forget the name, the shallow water equations.
Oh, yeah.
I forget the name of the guy, a famous man who did shallow water equations to control the water flow. So the only motion that it picks up is the spread open palm, and it uses that to say, okay, that's where we're going to make a rain cloud. Or if we want lava.
That projector.
Make it move.
Make
Do you
it
want
move.
to pull the projector off of that one and put it on here?
Sure.
It also does water displacement, so how there's a lot of water down here, and when I go and I pour sand in there, it displaces it, and so the water kind of
It will flow.
overflows and goes into, and that's all part of the shallow water equations. They kind of describe how water is going to move according to the gradient of the surface that it's on. It's going to move downhill, and how it's going to react to changes in its environment.
So the movement of your hand with the sand, we should be seeing that water pool into
Yep.
the lower portion here.
Yep, so you can see how it kind of goes up and then starts to flow down into these areas
We're seeing
and
the
spread out.
Yeah, this
the
one's
hill
getting a
up
little
here.
warm over here too, but definitely not that bad, and this one's been running for a while.
So, like I said, that's the only movement that the Kinect picks up. So anything,
Yeah, the fan was
the
making a
way
lot
the
of
program
noise,
works
so I
is that
took out
if
the frame and
anything
instead
that
of a loose wire
moves
that was
within
getting
1
hit by the
second
fan.
time frame is considered a
And so
body
I
part
fixed that
and is
part,
ignored
so it
unless it's your
wasn't rattling
hand
anymore.
spread open. So if I hold my hand here just flat,
You'll be
it's going to start to think that it's part of the terrain until I pull it away and it refreshes. Since the project is open source, we can actually go in and look at all of the code for this, and we can play with it. And so I took the water shader, and they had a few lines in there that they had put in already that you could change to turn the water into lava. So I made a bash script where I can actually switch between water and lava in the middle of the program.
And actually, I meant to do it the other way around.
And the neat thing about the lava is that it moves a little bit slower than the water, so it uses slightly different equations because lava's a little more viscous and isn't going to flow as nicely.